Hello children, today we have to discuss the topic photoelectric effect. It is section 11.3 of the lesson 11, dual nature. Okay, now this particular experiment, photoelectric effect, strictly confirms light is of particle nature. We have studied in wave optics, light has wave nature. In ray optics, we said that it is in the form of ray, Newton's corpuscular theory. But here again, it emphasizes light is of particle nature. Now let us see what is the word meaning itself. Photo. You just pause and then read electric effect. Photo, in the sense, it's a short form of the word photons. And Max Planck was the person to coin the name photo, and this effect came by, or this effect was found by Henry Hertz. Henry Hertz, he lived in the year 1857 to 1894. So in this word, the photon, what is photon? Photon was the word coined by Max Planck. He said light energy is emitted as packets. Packets, he named the word quanta. Max Planck's quantum theory, quanta. The energy of each packet is h nu, where h is Planck's constant, nu is the frequency of the radiation which is coming. So this we use here, Max Planck's quantum theory, that was explained by Einstein later, which he got Nobel Prize. We will do in the next video. So here we are discussing certain parameters with which photoelectric effect was studied. And few of them are: one, frequency; next one, intensity; third one, anode potential or the collector potential. So let us go in the detail. Number one, what is initially we have an evacuated glass tube. This glass tube is evacuated and you have a window like this. Through this window, light source is entering. This is a quartz window through which light is entering. And you have both the plates, the emitter plate or the cathode, collector plate or the anode, connected through wire to a battery and an ammeter. But here the current is very little current. So you have a micro ammeter. This is the symbol micro, 10 to the power minus 6 amperes. So this is the experimental setup which is done. And you can have also a commutator arrangement with the battery so that you can vary the anode potential. The anode potential you can make it as 0, positive, negative, depending on the voltage given to the battery. So that is a commutator arrangement, a variable arrangement. Okay. Now let us see a few terms. Now let me explain what is the word meaning of saying frequency. What do you mean by saying frequency? Frequency, simply colors. Just think about the colors. If you have colors like violet, indigo, blue, green, yellow, orange, red, you know that we use in the graphic signals red. Why? It has higher wavelength, means lower frequency. So as you come from red through violet, you can see that frequency goes on increasing. So what we are going to do initially is, you take a source, you can keep a filter here so that the filter can give you different colors of light, means different frequencies of the light. So you can do the experiment by changing the frequency of the incident source of light. Another thing, you are going to change the brightness. Intensity means brightness. How to change the brightness? Now suppose you have a torch lamp, you are putting it very close to your eyes, what will happen? Feels somewhat. So you remove away. So when you bring it close to your eyes, we feel it is highly bright. It's too bright, we will say. In cell phone and all, we reduce the brightness, auto brightness or minimum brightness. That reflection is very difficult. So that is brightness. And another option is you can change the anode potential. That I told you, by having a commutator arrangement over here, you can change the anode or the collector potential. Now let me see what happens if intensity is going to change. This intensity, I can give an example like saying small rain, again a bigger rain, heavy rainfall. So what will happen? Even boulders etc. is removed through the heavy rain showers. So you will say that when such a flood is coming on, boulders, big rocks are taken away. So even that can be moved by a heavy rain. But a small, a lighter patter, that kind of rain, you can see that nothing happens. Even the small sand itself is remaining there. So that you can think of intensity. The number of photons coming and showering, that you can think as intensity. So higher the number of photons, brighter the light. Lower the number of photons, less bright. Okay, so that is intensity. As intensity is increased, means more photons are coming down. Heavy shower, rainfall. So more photons. Comparing, falling on the metal surface, it is falling on the cathode or the emitter surface, more electrons are ejected. I told you, depending on the power of the rain coming down, means the number of raindrops coming down, the number of ejected boulders or the pebbles increases. Simple. So it is ejected. Each photon falling can eject one electron. So each one photon can take away one electron. So it's very clear, as you increase the intensity, when you are increasing the intensity proportional to I. You see, you have two words. I put the two words I and I. What is one I? Intensity. What is the other I? Photoelectric current. Both are represented by I. I proportional to I. It's a very important word. I means intensity of the incident photons. This is the current produced by the ejected electrons. So when I is going on increasing, this I goes on increasing. Clear? Directly proportional. Intensity directly proportional to photoelectric current. I proportional to I. Clear? Now, another parameter, frequency. So what happens for frequency? So before that, one more definition, that key definition, just understand, then it will be easier. Instantaneous ejection of electrons. What is instantaneous? No time lag. Immediately after the photons are falling, electrons are getting ejected. But there is a condition. From a metal, when light of particular frequency, not all frequencies can create ejection. So only for light of particular frequency or wavelength this happens. So electrons are coming out immediately, that's okay, fine, but the condition is only if there is a particular frequency. So ejection takes place only if the frequency exceeds a particular frequency. Clear? So coming back to that, as we move from red to violet, visual, you are coming from red to violet. What will happen? Red to violet, frequency increases. You know, violet to red, wavelength increases. Right? Highest wavelength for red. So lowest frequency for red. So when you come from red to violet, frequency is increasing. So I told you, you can take source, from the source you can take, using a filter, different colors. Now, at a particular frequency, when that particular frequency is attained, threshold frequency, the word is threshold. Threshold means a limit. We will say, I have certain limits which I won't cross. So everybody sets a limit for him or her. so that you are not going to cross that limits. That limit which you have set, that is your threshold. Similarly, that threshold frequency emission of an electron begins. So, once that threshold has started, emission of the ejection or the ejection of the electrons gets started. Now, as we move again, as we increase the frequency again and again, what will happen? The ejection starts and also the electron starts moving with higher velocity. So, initially they were moving, right? But now they start moving with higher velocity. When you go with higher velocity means what? Kinetic energy of the electrons increases. What is kinetic energy? Half mv square. So when V is rising, what happens? Kinetic energy of the electrons are increasing.